Okay, and now the next step for this process is to open up QGIS and take a look at our newly formed raster. So in order to do that, we have to go to Start, and we have to go find QGIS. Oddly enough, they're in alphabetical order. Here's QGIS 3, and I'm going to go ahead and open that up. So when QGIS first opens up, you have a blank template here. And what we'll need to do is you need to navigate to where you saved your TIFF file. And in mine, again, was on the desktop. So I'm going to expand the desktop folder here in the browser. And mine was called PDOL Lidar. And I got a whole bunch of stuff in there. But here's my DTM. And I'm going to click and drag that onto my map. And there it is. So that's the raster that we created using PDOL. So it took a LiDAR point cloud, and based on our inputs which were just we want ground points, that's what we get back. So that you have a bunch of cell values and you have lots of no data values which represent other things such as buildings, trees, water, things like that. So all we see in this is the actual ground surface. However, this particular the DTM, digital terrain model, is not projected. So we have to give it a projection. So you can see this little question mark right here. All right. So it has no coordinate reference system. So we're going to go ahead and click that little question mark there. Let me bring it over to my other screen. And mine are already in here, but I'm going to do this with you. What we could do is we could type out 28992 to look for the EPSG. So 28992, and it'll say Amersfoort/RD new, and that's the one we want. Okay. And what's really neat is it gives you kind of an idea of what's going on, like where it's going to be at, and that's exactly what we want. So we're going to go ahead and click OK once we get that. So it's 28992 in the filter. Click on this, click OK. Now, I'm a little new to QGIS. So when it brought that DTM in, it put it sort of in pixel space. So now you see it disappear there. All right. That doesn't mean we lost anything. What that means is it actually moved it where it thinks it is on Earth. So we're going to right click on DTM and click zoom to layer. There it is. Now, what you might want to do right away is save this project so you can, get back to it again. So I'll just click save. It's going to ask me where to save it. Give it a file name. I'll call it PDOL LiDAR. You can see I have a bunch of other stuff in there, but LiDAR, PDOL LiDAR. And just I saved it in the same folder where I saved all my other stuff. Make sure you know where you're saving it. So what gets produced is a GeoTIFF raster image where there are grid cells defined, like I mentioned before, as bare ground, and then everything else is no data, which is, vegetation or no points at all. Now, this is a 6-band raster. And in order to see that, we can go right click on DTM, go into the properties, which is the bottom option. Right click properties. I tell my students that all the time. Just live it, learn it, breathe it. Right click properties. And if you get this when it pops up like this, just go ahead and click OK. All right. Now, here's all of the information that we're looking for here. And you could see it's 6 bands. Now, the last two weren't created necessarily, but when we did the output type, if you go back to the JSON file, the output type was set to all. So what this means is you have the maximum, minimum, mean, and standard. I think standard deviation. I can't remember off the top of my head which one is which. Um, and so that's what all of these represent. For some reason, it didn't calculate band 5 and 6. I'm not quite sure why. Um, or maybe we have to calculate statistics. But the idea is it gives you all of this information in this particular raster. Now, um, that, like I mentioned, that was where the output type was set to all. So these statistics could be useful in advanced analysis for the precision of the surface you created. But for our purposes, we'll just go with the mean value, which is band 3. All right, that kind of makes sense. We're just going to take the mean values, and what we're going to do is extract those out. So we're going to go ahead and close the layer properties. And over in our processing toolbox, we'll go to GDAL, which is down here near the bottom, and expand GDAL. Then we're going to expand raster conversion. Um, and we want translate. Now, what essentially we're doing here is we set the coordinate system to one that it recognizes where it is on Earth. So this is in the Netherlands, so we set the coordinate system to match the Netherlands. However, the actual raster that we created is still unprojected. What we want to do is we're going to use what's called the translate tool, which in ArcGIS would be the project raster tool. And we're going to take that projection and we're going to make it permanent. And the output for this particular tool will be a raster with only one band, which will be our mean values, along with the correct coordinate system. So it's sort of, saving all that information in our final file. So I'm going to go ahead and double click on translate. Now, QGIS has very different inputs than, let's say, ArcGIS or ArcGIS Pro. So it takes a little bit of getting used to. This is what we have as our input. And what's really nice is it tells us already what we have the coordinate system set at, but we want to override that. And that sounds counterintuitive, but we want to override it with the same one. Okay. Um, because we want it to, oops, that's not the right one. Sorry about that. That one. We want to override it so it sticks, so it's saved that way. Now, what we're going to do is we're going to scroll down a little bit here, and we're going to add another command line here. And excuse me. Oh, wait, I missed something. I apologize. Oh, wait, no, I did not. What we want to do is we want to make sure that we only save band 3. Okay, so in the advanced parameters here, the advanced command line parameters, what we want to do is do a dash, a B, and then a space and a 3. So I'll let you look at the screen there. It's dash B space and then the number 3. And what that's going to do is tell the translate tool, hey, we're going to create a raster based on the third band. And then finally, we need to, under converted, it says save to it kind of says save to a temporary file. We're going to use this button here over on the right, the 3 dots. We're going to click on that and we're going to go save to file. So that's going to make a permanent output that we want. And it's going to ask you where to put it. Mine automatically went into PDAL Lidar. And I'm going to call this, what are we going to call this? We'll call this DTM underscore mean val. And I'm going to put a 2 on mine because I'll just overwrite mine. So you want it, that's what, you can call it whatever you want. So this is the DTM that we created. It's the mean values and the output is a TIFF file. Hopefully that makes sense to you. And then go ahead and click save. And mine says, yes, I am going to replace it. And then you click run. And that's it. Now the output, I'm going to go ahead and close this box once it's done running. You can look through this if you want. It just kind of tells you here's what the command was. And you'll see in here, here's the dash B3 we added to tell the translate tool, hey, we just want the third band. Okay, so I click close and you'll see it doesn't look a whole lot different than the original one. I'm going to toggle this here. So it doesn't look a whole lot different. The main difference is this one that we just created is been saved and projected. And it's only the mean value. So this range of values from 10.3654 to 167, those are the mean values. So now let's do a little bit of visualization. That word is hard for me to say apparently. I'm going to right click on this and go to properties. Right click on the new one and go to properties. And we're just going to change the symbology. And the symbology is right here. You click on symbology. Currently it's set at single band gray. What we want is uh, pseudo band, or I'm sorry, single band pseudo color. Excuse me. Again, I'm a little a little new to QGIS. So it's single band pseudo color. Then you pick you pick a from the drop down menu. I picked this one here, the Viridis, and then you click the classify button. You won't have all these at first. If you click the classify button, then you'll see all of these different it'll create the classes all by themselves. Let me bring this up again. Again, so I chose single band pseudo color. I chose the Viridis color ramp. I click the classify button and then I click OK. So it looks a little nicer now. I'm going to expand this over here in my layers and you can see it created lots and lots of classes. Now, what would be nice is if we added a background, sort of a background image in order to visualize this even more, kind of orientate ourselves in space. And what we're going to do is we're going to add some Bing imagery. Now, I don't use Bing almost ever, but for the purposes of this workshop, that's what we're going to do. So in your browser here, there's a couple of different ways you can do this. We can go up here. This very top button is Open Data Source Manager. So let's go ahead and do that. Now, what I did, for whatever reason, mine doesn't show up over here. So I click on the browser. So if I click on vector, these are all the different inputs for that. If you click on browser, you'll see down here, it says XYZ tiles. Now, what you want to do is we're going to add, I already have mine here. You're going to add, right click, new connection. Go ahead and click right click, new connection. And then you'll get this dialog box. All right. So what we want to do is then you want to add the word Bing aerial. That's just what we're naming it. That could technically be anything. And then in the handout and on the website, you can you can copy and paste this particular URL in there, and then just click OK. So once you click OK, you'll see it over here. Okay. I'm going to open that back up for a second. So it's Bing aerial, this URL here, which is actually the entire world. And then just click OK. You don't need anything in the authentication. You don't need to change any of that. So I'm just going to click cancel here. Once you have your Bing aerial created, you can go ahead and you can do a couple different ways. You can add, I just hit this button, add selected layers. Now, and then you can close the data source manager browser window. Now, obviously, we got to reorder these a little bit because it put the map on top. So I'm going to take my mean val and move it up one. Or how about with this? We'll take the Bing and move it down. I'm going to zoom out a tiny bit here just so you can kind of see it. So now we can kind of orientate ourselves in space. You can kind of, you can toggle this on and off to get an idea of what's going on here. And you can see there's lots of buildings here. You have the river running through town and this lake here. And none of that shows up in our DTM because that's water and other classified things. This is that quarry, which we'll get to in a bit, that you saw in the very first image wave in the beginning of the workshop, in the beginning of the handout. So there we are. The last step that we're going to do in QGIS here is we're going to fill in those holes. And because those are no data values, we can use a tool in QGIS to help us fill that, and that'll make the image look a little bit more appealing, so to speak. It does this by interpolating values from nearby pixels. Now, obviously, this isn't, anytime you interpolate anything, the answer is going to be non-unique. But for the most part, because most of these holes are buildings or water, I think we'll be fine with this. So the next step we want to do is we want to go to uh, QGIS over here in the bottom again. I'm going to close raster conversion and open raster analysis. And then we want this tool here called fill no data. So I'm going to double click on that. And we're going to change this to 25. The rest of this we can leave default, but we do want to save this. So we're going to save, just like we did before, save to file. And this time we're going to call it, I'm going to click on my old, so DTM underscore mean val filled, we'll call it. Now I've been doing GIS quite a while, and depending on how long you've been doing, I'm sure you do the same thing. But when you're doing GIS, it's always helpful to come up with naming conventions. I use the word project or underscore PRJ for anything I project. Not anything I project, meaning if it's already projected, I won't put it on there. I assume it's already projected. If I'm using any kind of a clip, I put underscore clip because when you're doing a lot of data processing, it's really, really easy to forget which tool got you to that point. So I document them. Now that we have file geodatabases, at least in ArcGIS, there's no penalty for long file names. So it's okay to add, I'll tack things on. So if I've clipped it and then I've, dissolved it and then, I'll put all that in the file name. It's just a little tip that I've learned over the years because I run a lot of tools. I mean, I'm more of an analyst than a map maker, and it can really get gunked up instead of raster calc 1 and raster calc 2. So that's just a little tip. So I'm putting in there DTM mean val, and that mean val is also telling us what we did because when we saved only band 3, and then the underscore filled to let us know. You could even put no data filled, but I'm just going to put filled. Click save, and then go ahead and click run. Okay, and then you can close the dialog box once it's done. And now what I'm going to do is I'm going to do the same process I did before, and I'm going to apply the same color ramp that I had earlier. So right click, properties, we're going to go to single band pseudo color. I picked the Viridis. Now you can see it's already being classified, but if it isn't, go ahead and click the classify button and click OK. I'll leave that up for a second. So now we have a raster that looks more continuous eh, um, throughout. So there's not a whole bunch of holes. Now, again, you always probably lose a tiny bit of resolution doing interpolation. But for the little bit that was done here, plus we already know ahead of time, this area is pretty flat. So it's not like you're going to lose a ton just by filling in those holes. But those are decisions that when you're dealing with raster data, you have to make in terms of how, especially interpolation. I do that quite often. You have to, that's why I use the geostatistical analyst, which allows a lot of checks and balances to make sure that the model I'm producing via interpolation, whatever method I use, whether it be Kriging or natural neighbor or whatever, that the output is as real as possible. It's always non-unique, but you always want to make sure that you keep your RMS low. And there's a whole bunch of checks and balances that go into that kind of thing, rather than just sort of running it as a black box and hoping for the best. So the next step now we're, is to get this to see what it looks like in 3D. So I'm going to make a new video for that particular step.